Dear students, previous class we discussed about Jacobi's symbol. What is Jacobi's symbol? N by P equals product I ranges from 1 to R, N by Pi all power AA, when P is a positive odd integer and if it can be expressed as a power factorization or prime factorization, that is P equals product I ranges from 1 to R, Pi power AA. Then N by P equals product I ranges from 1 to R, N by Pi all power A. Also we see that N by 1 equals 1 and some of its properties, M by P, if P and Q are any two odd positive integers, then M by P, N by into M bar P, M by P into N by P is Mn by P, as well as N by P into N by Q equals N by PQ. And come to the third property. When M congruents to N mod P, then M by P equals N by P. So the theorem is, or this result is immediate from this result is followed by legendary symbol. In legendary symbol, when M congruents to N mod of P for any prime P, then M by P is N by P. Here, P and what is P? P has a prime factorization, that is P is product I ranges from 1 to R, Pi power A. Okay, so M congruents to N mod P means, here M congruents to N mod, what is P? P means product I ranges from 1 to R, Pi power A. Okay, clearly this Pi power A and Pj power Aj are relatively primes to each other. Clear? So for all I differs from J, then Pi power Aa and Pj power Aj are relatively primes for all I differs from J. Therefore, this implies M congruents to N mod Pi power A. Clear? Okay. N mod Pi power A by using legendary symbol. M congruents to N mod Pi power A means here M congruents to, it is N mod Pi. Okay, again by the property. So M congruents to N mod Pi. M congruents to N mod Pi, where Pi is a prime, odd prime. Therefore, M by Pi is equals N by Pi by the result in legendary symbol. M by Pi equals N by Pi means it is product I ranges from 1 to R, M bar Pi or M by Pi, all power Ai equals product I ranges from 1 to R, N by Pi, all power A. Okay, that means, what is this one? This is M bar P equals N bar P. So when M congruents to N mod P, where P is an odd positive integer, then M by P equals N by P. Okay. Come to the next property. The next property says that Ax square N by P equals A square N bar P equals N by A square N bar P equals N bar P, where P has a prime factorization with A and P are relatively primes. This is an important property. A square N bar P equals N bar P, where A and P are relatively primes to each other and P be any odd positive integer. How? We have, what is A square N bar P? A square N bar P equals what is P? P have a prime factorization. P equals product I ranges from 1 to R, Pi power A. So this can be rewritten as product I ranges from 1 to R, A square N bar Pi power Aa all power Aa. Clear? Okay. That means that equals product I ranges from 1 to R, A square by Pi power Aa all power Aa into product I ranges from 1 to R, N bar Pi power A all power A, or N bar Pi or not pi power, sorry. That's okay, this one. Sorry, there is a mistake. A square n by p equals, so what is a square n by p? It is product I ranges from 1 to 1, a square n by pi all power a. So that can be rewritten as, it is product I ranges from 1 to 1, a square by pi all power a into product I ranges from 1 to 1, n bar pi all power a. But we know that for any prime, odd prime p, what is m square by p? That is always 1. For any prime p, for any odd prime p, m square p equals 1. So what is a square by pi? That is again 1 itself. So that means this equals product I ranges from 1 to 1 power a into product I ranges from 1 to n bar pi all power a. What is product I ranges from 1 to 1 to a? That is 1. So that equals product I ranges from 1 to n by pi all power a. What is this one? This is nothing but n bar p. So a square by p, a square n bar p equals n bar p, or a square n by p is n by p when a and p are relatively primes. Okay, right. So these are the properties of Jacobian symbol. Agreed. That is n by p into m by p is mn by p, m by p into n by q is n by pq equals n by p into n by q, and so on. Agreed. Now consider theorem. Let p be an odd positive integer, then what is the evaluation of minus 1 by p and 2 by p when p is an odd prime? In Legendre symbol, the evaluation of minus 1 by p is 1 power p minus 1 power p minus 1 by 2. Agreed. Similarly, evaluation of minus 2 by p is minus 1 power p square minus 1 by 8. Enough. So, in Jacobian symbol, the evaluation of minus 1 by p and 2 by p. So, here minus 1 by p, minus 1 by, in Legendre symbol, minus 1 by p, that p is an order prime. Here minus 1 by p, this p is not an order prime, which is nothing but a positive integer, because order positive integer has prime factorization. So minus 1 by p equals minus 1 power p minus 1 by 2. And evaluation of 2 by p. 2 by p is evaluated as 2 by p equals minus 1 power p square minus 1 by 8. Legendre symbol has same result, but there p is an order prime. Here p is order positive integer, has prime factorization. That is the difference. Agree. So how? Proof is, let p equals p1 etc. pn have prime factorization, p equals p1, p2 etc. pn. Enough. Where the prime factors are not necessarily distinct. The primes are not necessarily distinct. May have means p1 power some a1 whatever may be. So p equals p1 etc. pm, where the prime factors are not necessarily distinct. So minus p means p equals, let p equals product I ranges from 1 to m pn. That is p equals product I ranges from 1 to m pn. So this can be rewritten as product I ranges from 1 to m. Pi means it is 1 plus pi minus 1. That's only for sake of situation. Product I ranges from 1 to m, 1 plus pi minus 1. So, come to the product. What is it? It is 1 plus, then the next term is sigma I ranges from 1 to m pi minus 1. Okay? Plus the second term is sigma over I differs from j ranges from 1 to m pi minus 1 into pj minus 1 plus etc. Plus etc. plus what is the last term? Pi minus 1 into pi minus 2 into etc. pi minus. So 1 plus sigma I ranges from 1 to m pi minus 1 plus sigma I differs from j pi minus 1 into pj minus 1. Next term is sigma pi minus 1 into pj minus 1 into pk minus 1 plus etc. Okay. What is p? Pi is an order prime. Pi is order prime. Okay. Pi is an order prime. So pi minus 1 is even. Okay. Pi minus 1 is even. Pi minus 1 is even. Pj minus 1 is also even. Pj is also an order prime. So since pi and pj's are order prime, so except the first two terms or the terms after this two or the terms after second, all the terms after second is a multiple of 4, or the term, each term in the sum after the second is divisible by 4. Pi minus 1 is even, pj minus 1 even, next term pi minus 1, pj minus 1, pk minus 1, even into even into even. Okay, so since pi minus 1 is even, pj minus 1 is even, we have the sum after the second term. First term 1, second term sigma pi minus 1, so that the sum after the second term is divisible by p. That means p is congruent to 1 plus sigma I ranges from 1 to m pi minus 1 mod 4. Okay, pi minus 1 mod 4. That means p minus 1 congruent to sigma I ranges from 1 to m pi minus 1 mod 4. Agreed? Okay. That means p minus 1 by 2 congruent to sigma I ranges from 1 to m pi minus 1 by 2 mod 2. Okay? Mod 2. But what is minus 1 by p? But minus 1 by p equals product I ranges from 1 to m minus 1 by pi power, or minus 1 by pi, not a pi power a, only pi. Product I ranges from 1 to m minus 1 by pi. That equals product I ranges from 1 to m minus 1 power pi minus 1 by 2. Okay, why? That is from evaluation of minus 1 by p for p is an order prime from legendary symbol. So from legendary symbol minus 1 power pi, from legendary symbol minus 1 by p is minus 1 power p minus 1 by 2, where p is an order prime. Here pi is an order prime, so minus 1 by pi is minus 1 power pi minus 1 by 2. So it is product I ranges from 1 to m minus 1 by pi is product I ranges from 1 to m minus 1 power pi minus 1 by 2. Okay, so that means product I ranges from 1 to m minus 1 by pi minus 2 means, what do you get from there? We have, this is nothing but it is minus 1 power p1 minus 1 by 2 into minus 1 power p2 minus 1 by 2 into etc. into minus 1 power pm minus 1 by 2. Okay, yes. That equals minus 1 power sigma pi minus 1 by 2, where I ranges from 1 to m, product minus 1 power sigma I ranges from 1 to m pi minus 1 by 2. That is means it is minus 1 power sigma I ranges from 1 to m pi minus 1 by 2 mod 2, since pi is an order prime. Okay, but what is sigma I ranges from 1 to m pi minus 1 by 2 mod 2? This one. That is nothing but p minus 1 by 2. So this is nothing but minus 1 power p minus 1 by 2. So that is what there is. So evaluation of minus 1 by p, where p is an odd positive integer, then minus 1 by p is minus 1 power p minus 1 by 2. That's again followed from legendary symbol. Okay. Similarly, the evaluation of 2 by p. How to evaluate this 2 by p? So again you consider what is p actually. P is a positive odd positive integer. So here again p equals p1, p2, etc. pm. Okay. Now the evaluation of 2 by p is here. In legendary symbol it is when p is an order prime, it is minus 1 power p square minus 1 by h. Here we want to prove 2 by p is minus 1 power p square minus 1 by h. What is actually p square? P is product of primes. What is p square? P square means p is p1, p2, etc. pm. So p square is product I ranges from 1 to m pi square. Sure? Okay. That equals product I ranges from 1 to m 1 plus pi square minus 1. Okay. So you can rearrange it as that means p square equals it is 1 plus sigma I ranges from 1 to m pi square minus 1 plus sigma I ranges from 1 to m again pi square minus 1 into pj square minus 1 plus etc. Okay, what is p? P is an order prime. Pa is an order prime. Not p is an order prime, p is order positive filter. What is Pa? Pa is an order prime. Okay, order prime. So what about the Pa square minus 1 or Pi square? Pi square minus 1 is always congruent to 0 mod h. Since Pa is an order prime, 3 is an order prime, the least order prime. That is 3. 3 is an order prime. So 3 square minus 1. So multiple of h. 5 square minus 1. So multiple of h. So when Pa is an order prime, then Pa square minus 1 always congruent to 0 mod h. Now come to this summation. The sum in the right side sum. The sum in right side on the term except the first and second involves product of 8 into h, that is 64. Agreed. So all the terms except the first two in the sum, all the terms except the first two are divisible by 64. So that means from here we say that p square congruent to 1 plus sigma I ranges from 1 to m pi square minus 1 mod 64. All the terms in the sum except the first two is divisible by 64. This term is a multiple of h. Pi square minus 1 is a multiple of h. Pj square minus 1 is a multiple of h, and so on. So that means p square minus 1 is congruent to sigma I ranges from 1 to m pi square minus 1 mod 64. Agreed? That means p square minus 1 by h congruent to sigma I ranges from 1 to m pi square minus 1 by h mod h. Okay? Now consider 2 by p. What is 2 by p? 2 by p means it is product I ranges from 1 to m 2 by pi. But what is 2 by pi? For the evaluation of 2 by p, in legendary symbol for p is an order prime, it is minus 1 power p square minus 1 by h. So it is product I ranges from 1 to m minus 1 power p square minus 1 by h. Okay, that is product that equals minus 1 power product I ranges from 1 to m p square minus pi square, not p square, pi square minus 1 by h. Agreed? That means minus 1 power. Come on, what about this one? That is minus 1 power summation. Sigma I ranges from 1 to m pi square minus 1 power this one. That means minus 1 power of minus 1 power p1 square minus 1 by h into minus 1 power p2 square minus 1 by h into etc. into minus 1 square pm square minus 1 by h. So what is that equals, that gives minus 1 power. Come on, it is minus 2 by p equals minus 1 power sigma I ranges from 1 to m pi square minus 1 by h. That is same as minus 1 power sigma I ranges from 1 to m pi square minus 1 by h mod h. Okay, but what is that one? P square minus 1 by h, that equals minus 1 power p square minus 1 by h. So this is evaluation of 2 by p. Okay. So evaluation of 1 by p is, when p is an odd positive integer, it is minus 1 power p minus 1 by 2, and 2 by p is minus 1 power p square minus 1 by 8. Agreed. So these two proofs are followed from the legendary symbol. Clear? Okay. Now let us discuss the reciprocity law for Jacobi symbol. That is in next class. Thank you.